Welcome back, Anissa. When you were gone yesterday, we told everybody, I like the ribbon, by the way. We told everybody that if you experienced frustration yesterday, that they were allowed to give signs of grunts, groans, um, noises, animal noises mainly. So you're still allowed in those scenarios. You're going to need a few different sheets out today. Particularly, you do need to make sure that you have this sheet out. This sheet should look familiar. Make sure you got that. Also, there's another sheet that you need. You need that sheet. You should always have these ready to go. They are super important. Muy importante. Muy importante. What? Is that what he does? I was speaking Spanish yesterday in Algebra 2, 8th hour, and they loved it. In fact, after we got done, they said, would you please speak more Spanish for us? Because I know so little. So, Mi es muy guapo. Mi es muy strano. uh, tú eres muy tonto. Oh, no, I just called my student stupid. Okay, all right. All right. Good times. Speak Greek to you? Well, that's interesting. I better pause that. Okay. Sum and difference for sine. Sum and difference for sine. We are going to do sum and difference formulas, namely this. Does anybody know what the sine of 30 degrees is? 1/2. It's 1/2. Yes, you look at your chart, you remember it's 1/2. We're going to be able to figure out exact values for things other than 30 degrees, 45 degrees, 60 degrees. And we have to use some formulas. So this is what you want to write down. The sine of a plus or minus b is equal to sine of a times the cosine of b plus or minus the sine of b times the cosine of a. No, when you take the sine of a plus or minus b, you don't just take the sine of a plus the sine of b. It doesn't distribute like that. It's not multiplication. It's an operation, and it doesn't work out like that. So that's the formula for sine. Cosine's a little bit different. Whoa. Cosine of a plus or minus b is equal to cosine of a times the cosine of b minus or plus sine of a sine of b. So you can see that the formulas are different. Well, if we write it, let's say we had cosine of a plus b. Then down here, it would be a minus in the middle. Up here, if we had a cosine of a minus b, then down here it would be a plus. So that's what the plus and minus minus plus means. And finally, my last one, the tangent of a plus or minus b is equal to the tangent of a plus or minus the tangent of b divided by 1 minus the tangent of a times the tangent of b. There we go. So I wrote these down for you right here. See them? They're all right here for you. So when you guys are looking through your assignment and you need to reference something, that's the sheet of paper you want. This is what you get on your test, and you should know how to reference these formulas. Good? Let's give it a try. First example, find the exact value of the following. Sine of 23 degrees, I should have written degrees, times the cosine of 67 degrees plus the cosine of 23 degrees times the sine of 67 degrees. I want to find that exact value. And I realize that that fits a form. Yeah, it fits the form of sine of some angle A plus some angle B. What is A in this scenario? 23. What's B? So this really fits this. Sine of 23 degrees plus 67 degrees, which is the sine of 90 degrees, which is 1. Degrees, 90. Sine of 90 is 1. 90 is pi over 2 in terms of radians. Well, so Whitney asks a very good question. Should we memorize this? Generally speaking, most of these values on this table, over time, it's nice if you can memorize it. This is something that most of it I have been able to memorize. But Whitney, you're going to be able to use this on the test. The difference is that you need to be able to reference it at least. You got to know how to reference it. Now, you're going to be a lot quicker with these problems if you could get used to some of these. And we practiced this a few, about a month ago when we started this process, didn't we? So, okay, let's try a different one. That was too easy. What? B? Minus? Yep. Okay, so B. B says cosine of 2 pi over 3, cosine of 5 pi over 12, plus sine of 2 pi over 3 times sine of 5 pi over 12. Now, if you don't like the radians, that's fine. I'm going to work with the radians right now. You could always change them to degrees if you don't like it. 2 pi over 3 would be 120. 5 pi over 12 would be 75. So let's quick figure this out together, though, right now. Let's which form does this fit? Cosine of A minus B or plus B? Minus, yep. It's opposite for cosine. If you look at your original formula, the cosine is opposite. Plus and minus, minus and plus. It switches. What? So if it's a plus, it's going to be a minus. If it's a minus, it'll be a plus. So that's what it means when we flip it upside down. Okay? So I just have to identify what is A and what is B. A is what? 2 pi over 3, and B is 5 pi divided by 12. So I have the cosine of 2 pi over 3 minus 5 pi over 12. So I have to subtract those. Common denominators would be 12, so cosine of 8 pi over 12 minus 5 pi over 12 is equal to the cosine of 3 pi over 12, which is the cosine of 5 over 4, which is square root of 2 over 2. Very good. How do you like that? Deo says pretty easy. Let's try something a little bit more difficult. I minus because the cosine formula says I switch the pluses and the minuses. Any other questions? Going once. For example 2a, it says, again, find the exact value of the following. This time it doesn't fit into a sum and difference. We're going to write it into a sum and difference. when you look on your sheet, do you see what the sine of 15 is? Is it labeled there? No, but we could write it as a sum and difference of two that we do know. Are there two angles there that either add to 15 or subtract to 15? 45 and 30. So what I will do here is I will do sine of 60 minus 45. Oh, I'm sorry. You could use either or. You could use 60 and 45 or 45 and 30. It doesn't matter. It'll come out the same either way. Okay, so sine of 45 and 30. That's what you guys said. That's what we'll use. So if I use my formula from up above, that would be the sine of 45 times the cosine of 30 minus the sine of 30 times the cosine of 45, right? I can transpose this difference formula to this. Yes, no? So what's the sine of 45? 45 in radians is pi over 4. Well, what is the sine of 45? Square root 2 over 2 times, what's the cosine of 30? Minus, what is the sine of 30? What's the cosine of 45? So those values, we know exactly, and now we have an expression that we can write an exact value for. What's square root 2 times square root of 3? They already have common denominators, so we have the square root of 6 minus the square root of 2 all over 2. I cannot subtract those. In order to subtract radicals, they must have the same radicand. Must have, so if you had like 3 square roots of 2 minus 4 square roots of 2, then you can do that. What? Oh, yeah. Glad somebody caught that. I didn't make that mistake first hour. Usually if I make it in 1 hour, I make it in the other hour. Good job. Yeah, when you multiply fractions, miss that piece. I can't subtract radicals unless the number underneath the square root sign is the same. So if you had, say, 3 square roots of 5 minus 1 square root of 5, that would be 2 square roots of 5. You can do that, but if they're not the same radicand, you can't subtract them. It's done. So square root of 6 minus square root of 2 all over 4, that would be the exact value sine of 15. Cosine of 7 pi over 12. A lot of people don't like that one because it's in radians. Well, just switch it to degrees if you don't like it. What's 7 pi over 12 in degrees? 7 pi over 12 times 180 over pi. Pi's cancel. 7 times 180 divided by 12. What is it? 105 degrees. So we can rewrite this as the cosine of 105 degrees. Now, we either need to write it as the difference of 2 or the sum of 2. Are there 2 that we know exact values for that we can write as a sum? 45 and 60. So the cosine of 45 degrees plus 60 degrees. And now, using our formula from up above, we can write that in expanded form, namely cosine of 45 degrees times the cosine of 60 degrees. Is it plus or is it minus? Minus the sine of 45 degrees times the sine of 60 degrees. And now I just need to put the exact values in for these pieces and then evaluate them. What's cosine of 45? Square root 2 over 2. Square root 6, or cosine of 60. A half. Sine of 45? And sine of 60. So we get the square root of 2 over 4 minus the square root of 6 over 4. Yep. And so this was really valuable to be able to rewrite in terms of sum and difference. I like them apples. Right. Nope. Now, for, say, Kim and Levi, even though they took this class last year in regular track, we never did the rest of this stuff. We stopped with section 1, right? So this is all new. So challenging for you guys as well. Find the exact value of tangent of 19 pi over 12. Is that 19 pi? I can't read mine. So I would first convert it to degrees. I would take 19 pi over 12 times 180 over pi. And what do you get? 285. So we really want to do the tangent of 285. Well, the tangent 285 is the same as the tangent of what are two that we know that add to 285? 40, 240, and 45. 240 and 45. So those would be good choices. So now I use my tangent formula to represent this. The tangent of what? 240 plus the tangent of 45 divided by 1 minus tangent of 240 times the tangent of 45. What? So it's opposite on top and bottom for this one. Times tangent on the bottom. Does it? So the top part will be plus or minus. The bottom part will be minus or plus with the times in the middle. Where? Oh, you're looking at the wrong one, not this one. This one. You were looking at double angle formulas. We're looking at sum and difference formulas. We'll do double angle formulas on Friday. We'll cover the whole sheet. All right, let's give it a shot. What's the tangent of 240? Square root of 3. What's the tangent of 45? 1. Divided by 1 minus square root of 3 times 1 is the square root of 3. Nope, can't have a square root in the denominator. That would just be wrong, right? Yeah. Be nice, Devin. Okay, so what do I do? How do I get rid of that square root? Multiply it by 1 plus the square root of 3, the conjugate of the bottom. If you simply multiply by the square root of 3, you're going to get the square root of 3 minus 3. And that doesn't, get rid of the radical. So we multiply by the conjugate. And the conjugate would be, again, 1 plus the square root of 3 over 1 plus the square root of 3. Let's do the top. Square root of 3 times 1 is square root of 3. Square root of 3 times square root of 3. 1 times 1. And 1 times square root of 3 We'll reduce that in a second. Let's multiply out the bottom. 1 times 1. 1 times square root of 3. Negative square root of 3 times 1. And negative square root of 3 times square root of 3. How can you write the top? Yep, 4 plus 2 square roots of 3. How about on bottom? Negative 2. You can divide them both by negative 2. 4 divided by negative 2 is 2 divided by negative 2. Negative 1. So that phrase can't reduce parts. We didn't cross off anything with the 2. We really factored a 2 out of the top and divided off the bottom is what we did. Here, 1 and negative 3 is negative 2. Okay. Oh, the negative 2 in front. 4 divided by negative 2 is negative 2. 2 divided by negative 2 is negative 1. Okay. We're going to skip example 4 where we prove something. We would like to prove it, but we don't have time. So we're going to go to this piece. And this is sums of sines and cosines. And so this is some excellent material. I'm going to borrow this just for a second. Thank you, Tyler, so I can write it down. And it looks like this. Given a sine of x plus b cosine of x equals k times the sine of x plus phi. Phi. Phi is just an angle. Could be in kind of like theta. Yeah. Your book uses phi, and so we'll use that. Phi was the Greek letter for pH. They didn't have a letter H. They had a letter P, pi. And so given that, here's the idea. If we have a function that's written in terms of sine and cosine, we would like to be able to write it so it's just sine. For example, would you know how to graph this one right here? No. But would you know how to graph it if it was just sine? Yeah. So we want to take something that is in terms of both sine and cosine and write it as just sine so we could graph it. That's our goal. Now, all you need to know is how to convert between a and b and k and stuff like that. Okay? Well, here's what we know. K is equal to the square root of a squared plus b squared. Nope, can't square root parts. If it was multiplication, you could do that, but it's addition, so we can't do that. So that's the first thing that you need to know. And second of all, phi satisfies cosine of phi is equal to a over the square root of a squared plus b squared. And sine of phi is equal to b over the square root of a squared plus b squared. It looks really bad, but I'll tell you right now that this is actually easier than the stuff we just did. Yep, I'll show you. It's a lot of stuff, but that's it. It's really quite easy to work with. And we'll do example 5 to just show you how. So again, we want it for number 5, we want to write it in terms of sine only. and then we want to be able to graph the function. Sine only and graph the function. Well, it says given a times sine of x plus b cosine of x. So first we have to write it in that form. So f of x is equal to 6 sine of theta minus 3 cosine of theta. I'm going to identify a and b. What is a? 6. What is b? Negative 3. Well, if I use this formula, I have to find, so what I have to find is k, and I have to find phi. And once I do, I can then graph it. That's all I got to find. So let's do that. K is equal to the square root of a squared. What's a squared? 36. Plus, what's b squared? 9. So k is equal to the square root of 45. We'll write it as a decimal. Square root of 45. 6.7. Now we just have to find phi. Well, you can use either one of these. Levi, which one would you like to use? Would you like to use the cosine one or the sine one? What? You want to use this one? Okay, so all I do is I write sine of phi is equal to b, which is 6. Well, I'm sorry, negative 3. Divided by 6.71. Okay, so let's do that. How do we solve for phi? Inverse of sine. Inverse sine of negative 3 divided by 6.71. Oh yeah, so when you're in mode, make sure you're in radians. Second sine negative 3 divided by 6.71. We get negative 0.4635. So write down negative 0.46. So now I have my function. F of x is equal to 6.71 times the sine of x minus 0.46. Let's graph it. What's the vertical shift? 0. What's the amplitude? 6.71. I draw my graph. I go up to 6.71, down to negative 6.71. What is my period? 2 pi. Or 6.28 because I'm working in decimals here. pi is 3.14. Pi over 2 is 1.57. 3 pi over 2 is 4.71. What's my horizontal shift? Where does sine start? 0, max or min? 0. But shifted 0.46 units. How much is 0.46? About a third of the first one. Not half would be like 0.75 or so. Right? So we're going to shift it over about a third or a fourth. Okay? So I move that first spot about a fourth over. And this one I move about a fourth over, a fourth over. So the idea is we were able to sketch this graph. We were able to sketch a graph of 3 times 2 sine of theta minus cosine of theta. That's how we did it. Tomorrow, full work day. If you want to write down the assignment, here it is. If you'd like to get started tonight.